what you say, hijacking by pharmacology and genetics. I mean, I think what happened with the understanding of cancer increased substantially in the last 20 years. And we've discovered, oh, it's this accumulation of genetic anomalies. And it gave pharma companies something to do about it, or it gave researchers something, targeted therapies which are heralded. And then they realized, Pandora's box opened, because you can have a targeted therapy, and then 2 years later you have a resistance to that targeted therapy, and then you can create another therapy that treats maybe some of the patients that have the mutation and so forth. But that can only go so far, and that economically what is more affordable is looking at preventative measures, or what is going on, either by tracing. It strikes me that you're almost tracing back the signature to the contaminant, whereas you're looking at known I mean, I knowingly grew up with a lot of pollution, and I'm curious about, you hear about low levels and being fine and things like that, but what isn't fine? At what point is it not fine? And what are those pollutants? Everybody sort of talks about air pollutants, and I think you're working with one in particular. I was wondering if you could maybe touch on that for us.
Air pollution is surprising, because we keep on finding associations of air pollution with health effects. In Switzerland, can you imagine that? In Switzerland, of all places, you find association of air pollution with cardio or with other health effects. Obviously, for cancer, we're talking about lung cancer. Of all the places, it's clean there, and you find effects. It's surprising. The problem with environmental exposures, with many of them, for endocrine disruption, dioxins, air pollution, is that they're widespread. It's low-level exposure in Western Europe. We're not talking about what happens in China, Africa, and all other places in low, medium-income countries. We're talking about Western Europe. I'm not even talking about Eastern Europe. I'm talking about Western Europe. It's many of the classical environmental pollutants are low. But, you have exposure throughout life and exposure of the whole population. So you have a low risk at the individual level, which, exerts its effects in the whole population. Everybody's exposed to air pollution. Everybody. So even if the risk is low, we're talking about a relative risk of 10%, 20% increase. Nothing to do with tobacco, which is 1,000%. No, we're talking about 20% increase for air pollution per 10 micrograms per cubic meter for the small particles. 20% is not so high as 1,000%. But it is all the life, and it's everybody. So you get quite a lot of cases. This is the issue with environmental exposures. And it's very difficult to do research for some of these, because it's easy to do research at high exposures. You do research in low exposures, it's very difficult. And we have, failures, big failures. Endocrine disruption research, big problem. We haven't really advanced. We need more money for endocrine disruption research. We have failed. We haven't developed the methods to evaluate them. Yeah. And it could be very important.
Well, I think you need an international consortium, and you need more money. Is that a fair summary?
Well, we can work together on that.
Yeah.
We actually are working together.
Oh, I see. Do you want to tell us a bit about your collaboration?
Well,
Is it private?
I wanted to mention one other thing, though, Barbara, that I thought was really important, and that is that, because we mentioned the idea of identifying causes, and you need to know the causes to prevent, etc. But I think the other thing that sometimes strikes me is that we're still very poor at early detection. And again, it's another area where I think there are amazing opportunities. And we've almost heard this word, cancer moonshot thrown about lately. But this is one area where I think it's almost a technological problem. It's an organizational problem. And I think it is one area that, again, it's going to take an awful lot of people coming together. But it's something that is feasible, it's doable. There are so many potential early detection preclinical markers at the moment. We had a meeting in IARC a few months ago on all of the groups working on circulating tumor DNA. So little bits of DNA from the tumor that are dispersed into the bloodstream.
This is a technology, basically draw some blood, take some urine, and find The signature,
traces of the tumor.
yeah,
You can find
yeah.
traces that you can, and
Yeah.
there's publications coming out now which show that you can, for individuals with grade 1, stage 1, very early tumors, in some of these are early studies, you can find traces of the tumor from a blood sample. And so the idea is that, you know, we need to be able to just show that whether you can do this 1 year, 2 years, 3 years before the actual cancer becomes clinical. Because, you know, the major cancer problem is late stage detection, late stage at diagnosis. So there are, you know, this idea of circulating tumor DNA, for example, Illumina just announced there 2 months
the
ago
Grail.
that they're putting
Yeah.
$100 million into this. They
Yeah.
see the opportunity as being so important and potentially so profit-making
Yeah.
that they have put together $100 million. And I think this is something whereby, you know, within Europe, we have the expertise. We have the population cohorts. We have UK Biobank, we have EPIC, we have dozens of other large population cohorts that could be used in order to be able to identify these sorts of biomarkers and test them. So I think there are immense opportunities for early detection, but again, it's this idea that no one group can do it. You need to somehow organize it and do it in a rational way and bring everyone together. And it is almost the sort of thing that is deserving of the word moonshot, because it is a technical problem.